Hi, our learning goal is to solve a systems of equations using an elimination. The work is in IXL grade 10, M10. So the big idea is we've been working on solving systems of equations, and what that means is finding where the lines cross on a graph. So this is the solution for a system of equations, and we represent the solution as the x variable and the y variable. That's the solution. We tell the reader where the dot is on the Cartesian graph. In our last lesson, M8, we did solving through substitution. And this lesson, we're going to solve again, but we're using a different process. We're using the process of elimination. And what that really means is we're going to eliminate a variable. We're either going to get rid of an x or get rid of a y. So this is how we do it. We have two equations. We have an equation A and an equation B, and the steps are outlined for you here if you'd like to follow a step-by-step process. So step one, it says make sure equations have opposite x terms or opposite y terms. So you can see here that the y terms are similar. We have 10y and 10y. Let's write this out again. We have 4x plus 10y equals negative 2. That's one equation. And the next equation is 10x plus 10y equals negative 2. Now, if I have 10y here, what would happen if I subtracted 10y? That would mean 10y would disappear or be eliminated from both equations. But we can't just subtract one variable. We have to subtract everything. Okay, so we're just going to go step by step, and we'll do one at a time. What's 10y subtract 10y? That's 0, right? There's nothing left. But what if we do this now? What if we have 4x take away 10x? That leaves us with negative 6x. And what if I have negative 2 subtract negative 2? That would be negative 2 plus 2, which is 0. So what that tells us is that x equals 0. Okay, so we've done step 1 and step 2. Now we're on step 3. Plug the result of step 2 into the original equation. So we can plug it into either equation. It doesn't matter. So let's pick equation B, where we have 10x plus 10y equals 10. We're going to take x equals 0 and put it in there. So we have 10 times 0 plus 10y equals 10. So that gives us 0 plus 10y equals 10. Now we just divide both sides by 10. So y equals 1. So the solution then is 0 and 1, because x is 0 and y is 1. So what that means is on the graph, the lines are going to cross here at 0 and 1. Okay, oops. Let's take a look at another example. We're going to solve using elimination these two equations. Okay, I'll write them out so they're a little bigger. The first step is to make sure that the equations have opposite x or y terms. And we can see here that they both have a 3y. So we have negative 10x plus 3y equals negative 11. And we have 5x minus 3y equals 16. Okay, so if we're going to get rid of the 3y, we can just add these two terms together, right? Because if 3y plus negative 3y would be 0, so we're going to add the two terms together. So that leaves us with negative 10 plus 5x, which gives us negative 5x, equals negative 11 plus 16 is 5. Now we know that the x value has to be positive, so we're going to divide both sides by negative 5. So x equals negative 1. Okay. Now we're up to this step here. We're going to put the result of step 2 into one of the original equations, and it doesn't matter which equation you use. We can pick this one. So we have 5 times negative 1, because we now know x is negative 1, minus 3y equals 16. So it becomes negative 5 minus 3y equals 16. Okay, we'll add 5 to both sides. That gives us negative 3y equals 21. Now we have to get the y by itself. We're going to divide both sides by negative 3. So y equals negative 7. Now we're going to write y equal to negative 7, and we have x equal to negative 1. So we can write our solution as negative 1, negative 7. And what that means is that the two lines are going to cross at negative 1 and negative 7. The lines will cross here. That's where the solution for the two lines crossing is, using the process of elimination. Okay, the work is in grade 10, IXL M10.